Hello, my name is Jennifer Thompson. I'm a meteorologist here at the National Weather Service in Norman, Oklahoma. And today we're going to go ahead and show you the process we go through for launching weather balloons. And we do it outside here at the National Weather Center. Let me just first explain kind of the process. We fill up a balloon and we launch it twice a day, both at 12 Zulu time and 0 Zulu time. In Central Daylight Time, that's 7 a.m. and 7 p.m. We do launch them at special times as well, either to support hurricane operations or to gauge the current state of the atmosphere the day of severe weather events. So one of the cool things is that we're one of 90 offices nationwide that do this launch, and there's also about 1,200 sites worldwide. And we all launch at the same time each day. So we get a snapshot of the atmosphere worldwide that helps piece together how the atmosphere is behaving at that moment. And then once we launch those balloons, all of the temperature and the humidity and the wind data is fed back to us. Each office receives their own data, and then we forward it on to our modeling center in Washington, D.C. And all those observations are used as a starting point for the weather models. So with that background, we'll go ahead and get the balloon started. Okay, so here is the weather balloon right here. It's made of latex, so it's able to expand quite nicely. And so what we're going to do is we're going to hook it up to the nozzle here and fill it with gas. But first, let me tell you what happens when we launch the balloon. We have to fill it with a gas that's lighter than air so that it'll rise to the top of the atmosphere. And we use this mechanism here that has all of these weights to allow us to control how much gas we put into the balloon, because it's not going to be the same from day to day. It's going to depend on the weather conditions at that time. If it's icy, then that really throws a wrench in things and we have to add a lot more gas. If it's windy, we have to add more gas. If it's colder, we add more gas, but if it's hot, we get that natural buoyancy in the atmosphere, so we can kind of not put as much gas in there. So that's how that works. I'll go ahead and hook this nozzle up to the balloon right here. Tighten this up. I like to put a weight here so it doesn't pop off here. And this will control how much gas, like I said before, goes into the balloon. And once the balloon fills up with just enough gas that we've prescribed here, it'll lift up here and it'll cut off the gas flow. So we will go ahead and turn on the gas. So now we're in the helium cage, and these are all the tanks that we store to fill up the balloons. We also have a couple of backup helium tanks inside the building in case we get freezing rain or ice, which prevents us from coming out here and getting into the cage. So we do launch the balloon in all weather conditions except for thunderstorms because of lightning. That's dangerous. And we use helium at this particular site because it's lighter than air. So for now, we'll turn this tank on and start the gas flow, and we'll turn the regulator just so to control the flow. Okay, so as you can see, the mechanism here is floating off the base, so it has shut off the flow of helium to the balloon, and we will get the rest of the train set up. Okay, so now the balloon is inflated, we'll finish preparing the rest of the train. Here is the parachute that will prevent the radiosonde from falling at terminal velocity once the balloon pops. And then it's attached to about 25 yards of string. At the end here we will attach to the radiosonde. And we have to have a really long piece of string to separate the measuring equipment from the balloon, just so that the radiosonde doesn't measure the heating that occurs from the thermal expansion of the balloon as it rises to the top of the atmosphere. So now that we have done that, we will go ahead and attach the train to the balloon. So we will take this here and tie it around the neck. And then we will go ahead and kind of just loop it on this hook here. And then we will grab this piece of string and we'll start taking the balloon off of the nozzle. So we just fold the neck of the balloon here and we close it off with this string. Okay, so now that that is finished, we will go ahead and grab the radiosonde. Okay, so here is the device that we use to measure the observations. It's called the radiosonde here, and it has 3 sensors. We have the thermistor here, which measures the temperature, and the hygrometer that measures relative humidity. It has a GPS sensor in here that tracks the location of the balloon as it rises. And as the balloon changes, location and height, it also is able to calculate wind speed and wind direction, as well as the atmospheric pressure at the spot that it's taking measurement. Here is the antenna, so that it relays all of that information through a radio frequency back to us. It takes measurements about once every second, and so we're continuously receiving that data until the balloon pops. A typical flight usually takes about 2 hours. And one thing I forgot to mention is this does have an internal battery, so it has just enough juice to last for that 2-hour flight. So we will go ahead and baseline the sensors and then tie it off. Okay, so one other thing that we do here is we go ahead and write on the radiosonde the location that we're launching from, in this case Norman, Oklahoma, and the time of the launch. So it is October and 14th, 2020 at 0Z. So whenever this lands somewhere, maybe in your backyard, you'll know where this came from. Okay, so our radiosonde has been baselined and we have armed it. So now we will go ahead and attach the radiosondes to the rest of the train. Double knot it here. And so now our flight train is complete. We have our inflated balloon, our parachute, our 25 meters of string, and our radiosonde. So now we're just ready to let it go. So we'll just go out here, make sure we go out far from the building. Depending on the wind direction, we can either exit the building on this side or the other side, but since the wind is coming out of the south, we exited on the north side. Okay, so I will go here and release. Okay, so now we're ready to launch. 3, 2, 1. Okay, so now that we've launched the balloon, we are receiving data now back in our office every second. And it'll take about roughly 2 hours for it to pop. But as that balloon rises, the atmospheric pressure decreases. And because of that, the latex balloon will expand until the point where it can't expand any longer, and which is about 20 feet wide. And then it'll burst. And then we will get notification that we've stopped receiving data. And then we will send all of that information over to our modeling center in Washington, D.C., where they will use that as input to our weather models. So just again, we do this every day, twice a day. We also do it for special launches for severe weather, just to see if the ingredients are conducive for tornadoes or any other severe weather risks. And we also do it in support of hurricane operations to get a better handle on the future path of those hurricanes. So thanks for your time, and we hope you enjoy it.